All right, good evening, everyone. My name is Dhananjay Kumar, and I welcome each one of you in NG, another webinar of NG India. As you know, we have been doing webinars each second Saturday, and we try to bring you the topics which you really use in your project. They ask you in your client interviews, in your job interviews. And today I'm very excited that we are blessed to have none other than amazing Deborah Kurata teaching us RxJS. I tell you that when I started learning Angular back in 2016, I started learning Angular from the course Deborah had on Pulver's site. She has many courses there, but I started with that Angular fundamental course. She's a great teacher. She's inspiration to all of us. And I'm very sure that we are going to have a good time today. So, Deborah, welcome to India and Indian developer community virtually. And I hope one day you'll be here in real too. So, over to you, Deborah.
Thank you. So, RxJS and Angular, action and data streams. How do you react to Angular, it's really early here, sorry, good morning, good evening. How do you react to actions in your Angular applications? Well, first of all, what do I actually mean by applications in this or by actions in this context? It could be a click on a button, typing text into a text box, pressing a specific key, and so on. So, for example, you click on a button that performs a calculation or modifies something on the screen. You type text into a text box that is maybe search text, and you then are going to run a search. You toggle a UI element, you click for the next page of data, and you expect that next page of data to come. You log a user in, and so you suddenly change the UI based on that user by their preferences and by what they're allowed to access. Would you consider using RxJS streams to react to those actions? Hopefully the answer is yes. Hi, my name is Deborah Kurata. I'm a software developer and a Pluralsight author. I've done a bunch of Angular courses and some C# ones as well. We just updated our Angular NGRX to the new actions and all of the creators. So if you're interested in NGRX, we've got that there. So with that, let's dive right in. Let's start by talking about what I mean when I'm talking about data streams versus action streams. When I talk about data streams, I'm referring to the stream that we get back when we do an HTTP GET. So it's one and done. It returns the data and completes. And so this is kind of a overly cartoonized marble diagram where the vertical line is indicating that it has completed. So one and done. There isn't anything more that we can emit into that stream. It's finished. It gave us the data, and that's it. When I think of an action stream, I'm thinking of something that's able to continue so that we can continue to emit values into that stream. So in this example, we first emit a 42, and a few minutes later, we emit a 15. So for example, the user clicked on a product on a list with an ID of 42. We can emit that into the action stream. Then later, the user picks a different product, and we could emit its ID into the action stream. So that's what I'm meaning by data streams versus action streams. Okay, so this is the sample application we're going to be kind of talking about for the next little bit. Here we have on our left our list of products, and on the right the details. So when the user picks one of the products on the left, the detail for that product appears on the right. So relatively straightforward because we want to focus on the technique. I don't want something too complex. Okay, so how would we build the data stream for that application? Well, of course, the first thing that we do is define the structure of the data using something like an interface. So here's our interface for our product. We have an ID, product name, and so on. So those are all of the elements for the product entity. Now, if you're like me, you've probably created gazillions of these. This is a service class that uses the classic pattern for retrieving data. So it's a basic service. It has a getProducts method that returns an observable of product array, issues an HTTP GET request, and does something with that. I just have it doing a tap, potentially through our pipe, of course, has our error handling, and it returns an observable of product array. So we've probably seen code like that often. What if we instead of doing it as a method, here this is a method, getProducts, and we're returning a value from that method. What if we instead did it as a property and made it declarative? So we could instead follow a declarative pattern for retrieving data. So if you notice, the information to the right of the equal sign is exactly the same as in the prior one. So the code below here is the same. All we're doing is we're assigning it to a property of our service instead of defining it as part of a method. So that is our data stream. By defining it as a declared property, we can do more with it, and we'll talk more about that in a few minutes. But that's our data stream. In our component, then, we can reference that data stream by simply setting a local products dollar property to the result of, or to the value of our products dollar property. Notice the dollar suffix on these. That's a convention that some people use to indicate and to make sure it's clear when somebody's reading this code that we don't have an array of products there. We have an observable of an array of products there. And so you'll see that convention in a lot of samples, and maybe you use it in your code as well. All right. What do we do with this then? In our template, we can then bind to that directly using the async pipe. So here we've got our products dollar, pipe async, and we're using the as clause as products. So what the async pipe does is it automatically subscribes and it automatically unsubscribes. So we don't have to take care of or manage any of those subscriptions. The as clause, what it does is it emits the value from the products dollar observable into that variable that we can then use any place else within this element on the template. So we can do let product of products, and we can work with that variable, and it will have our array of products in it once it's been emitted. Okay, so that's our data stream. It emits one time and completes, and it has our data. Okay, and again, if you notice, because I need to kind of fit this on the diagram, my objects just have the one property showing, but you can imagine that's the whole big, all the properties of the saw, the rake, and the axe. Okay, all right. So why? Why would we want to do this? Well, one reason is we can improve our change detection. By using the async pipe, we can change our change detection to on push. What that does is that can improve the performance of our user interface. Another reason why we might want to use this declarative approach is we can leverage RxJS operators much more easily. We can have much more code in our service working with that stream as a property of the service. And we'll see some examples of that shortly. We can also compose streams. If you've watched any of my other talks, I did a talk at ngconf about composing streams. And you can also react to user actions, which is where our focus in this talk is more going to be on that reactivity, those actions that we want to respond to and have our user interface change based on what's going on with the user. So that brings us to action streams. What is an action stream? How do you create it? And so on. All right, well, we create action streams using a subject or a behavior subject. A subject and behavior subject is a special type of observable that's multicast. It is an observer, meaning it has next, error, and complete methods, but it's also an observable. So we have the as observable to get the observable portion of that subject. So notice our code up here. We have two separate properties. The first one we're making private, and we are setting it to our new subject. The reason that we do that is we don't want any other code in our application other than this frequently service being able to access this subject. So we would declare this in one of our services. In our case, we would put it in our product service, and we only want the service to be able to access the subject. Why is that? Because the subject has next, error, and complete methods. We don't want some other random bit of code or some new developer joining the team and suddenly nexting into our stream or completing our stream or something like that. We instead only want to expose the read-only part of the stream, which is that observable part of the stream, which is what the second property is for. So it's exposing the read-only portion of our subject, which is that observable. Then any other code, our components, any other service can access that and retrieve, subscribe to them, probably with an async pipe in your template, and can receive then any of the emissions from that subject or behavior subject stream, that action stream. Okay. What's the difference between subject and behavior subject? This is kind of a common question. And the primary difference is that a subject has no initial value. What will happen is when somebody subscribes, one of your components subscribes, your async pipe subscribes, it doesn't get anything until something is emitted into that stream. So as soon as something's emitted into that stream, then it will get the emitted value. If something subscribes later after that, it won't get anything until the next thing is emitted from that stream. A behavior subject, on the other hand, has a default value. And when the first subscriber comes along, the first async pipe, for example, comes along, it will emit that default value. So it will get a 1 into the stream. When a later subscriber subscribes, again, maybe with an async pipe on another portion of the screen, what will happen is it will get the last emitted item. So if later a 7 was emitted into this subject stream, and then another subscriber subscribed, it would get that 7. Okay, so subject has no initial emitted value on a subscribe. Behavior subject always has some value that it's going to give you on a subscribe. And we'll see how that matters here in a couple of our examples coming up. All right, so once we have an action stream, it's not going to do anything unless we emit a value into it. So frequently this is done by creating a little method that we'll call our next. Now, because we've made our subject private, this little method needs to be in the same piece of code where we're declaring our subject, frequently in a service. So again, in this example would be in our product service. So here we have our product service that has our product selected subject, and then it has this change selected product method. Any component anywhere in the application or any other service can call this method and emit something into the stream. So any piece of code can say, hey, I have a new selected product. So if you have multiple ways that a user can potentially select a new product, maybe a next button on the screen and a selection and a drop down or whatever, any of those pieces of code can simply call this method, and you've got a very consistent way that you're passing that information throughout the rest of the application. Excuse me. All right. So this is our action stream. When the user clicks on something in the user interface or makes some kind of action, you're going to have an event binding on that action. In your component, you're going to have a handler for that event, and that handler is going to call this change selected product, which is going to emit whatever we want into the stream. So that can be anything. You can think of this as kind of your action payload. So you've got something that you are going to want to pass into that stream that you can then work with. Maybe it's a user ID, maybe it's a user login name, maybe it's an entire user object, maybe it's a Boolean. Yes, the user clicked this on and now they've turned it off. So you can emit anything that you want into this action stream. And then if the user does picks a different one, logs out, whatever they're going to do, you can emit something else into the stream. And that stream will just continue to go until you don't need it anymore, or it errors out or completes. Okay, so that talks about the basics of the streams, but how do we actually make it then work? So the user is going to click on a hammer and we want to show the product detail. So we're emitting that hammer ID, product ID, into the stream, but how do we then make it show the detail? What's that last step that we need to do? That's where our data stream meets our action stream. So that should be a name of a movie or something, maybe, I don't know. All right, so one of the ways to do this is with combinelat, which is an RxJS creation function. RxJS has literally 100 creation functions, operators that you can use. And when you're attempting to do something like this, there are a set of operations and creation functions like combinelat and merge that help you work with multiple streams. I use combinelat a lot when combining my data stream with my action stream. So here is my combinelat statement. I'm combining this dot products, that was our data stream, with this dot product selected action, which is our action stream that emits in, excuse me, the last product that the user selected. So combinelat combines multiple streams into a new stream. And you can have more than two. You can have 3, 5, however many streams here that you want. What this does then is uses the latest emitted values from each of its input streams. It waits for each input stream to emit at least once before it starts emitting. Now that might sound like just a bunch of words, but what that really means is that it will wait. So if you've ever been writing some code and suddenly realized, hey, I can't do this action until I know for sure I have that data. So I can't process the selected product until I have that product data. I somehow need RxJS to wait. How am I going to make it wait? Should I put a timer on it and kind of guess how long? No, you don't want to do anything like that. By simply doing a combinelat, it will wait to process any product selected action until it has the products returned. So this is like magic. This combinelat does so many wonderful things for us. So what does this do then? Once the products dollar stream has emitted our set of products and this product selected action has emitted at least once, it will emit an array of values in order, one for each input stream. And before I talk too much about what that line means, I just want to bring back the idea of a subject and behavior subject. If product selected action is defined as a subject, it will not originally emit. So in this example, it might make sense when the user first sees the screen to not have a selected product and to not have this emit until the user actually picks something. So that scenario, it makes sense for this to be a subject. But this might be something, a different kind of UI where we want to show them their most recent selected product. If we have product selected action as a subject, it won't emit anything. And when we bind to this, it won't show us anything. We would want to use, in that case, a behavior subject and emit into that stream the last selected product or their current selected product or whatever we want to be the default appearing. So that's why it really makes a big difference whether you're picking a behavior subject or a subject. Excuse me. All right, so this emits an array of values in order, one for each input stream. Now, what does that mean? It's going to emit something that looks like this. So we've got an array of products, which is the thing that's emitted from this .products dollar, and we've got the product ID, which is what's emitted from this .product selected action. So it's an array where the first element of the array is that emitted value from the first stream, and the second element of the array is the item emitted from the second stream, and if we had a third stream, it would have a third element in the array, and so on. So once we have that, what are we going to do with it? Well, we're going to pipe that value in, and we want to map that into something. So what the heck is that syntax? That's basically array destructuring. So instead of having something like map A, console.log, A sub 0, A sub 1, using the array syntax because we're getting an array, we're using array destructuring, which simplistically lets us name our array elements. So we're going to name our first element here products because it's the array of products emitted from that first stream. And we're going to call the second element of that array product selected action because it's the ID emitted from that stream. It just gives us a simpler way to keep track of those variables instead of having to use array syntax. So then we're going to simply just do a find and look up that one product in that list of products. And what that does then is it lets us display that data. All right, re-executing, the pipe then is re-executed when another value is emitted. So again, our data stream is one and done, it emits and completes. Our action stream, though, if the user picks one, the combine latest will emit both. So it's giving me the array of products and that number. Now, if the user then picks a different product on the list, it will re-emit, it will recombine latest, and it will give me the most recent, the latest, hence combine latest, the latest item in each stream. So it'll give us again our data and again our ID, and there it is available for us in our code. So we can again then find that ID in that list. We don't have to do anything else. We don't have to copy the values into a array somewhere. We don't have to do anything to hold on to that. Combine latest will automatically hold on to those values and keep giving them to us every time we request them when something else is emitted. All right, so our steps: define a data stream, create an action stream, emit a value every time an action occurs, and combine the action and data streams. Now let's look at a little bit more complicated of an example. Now, ignore the quality of this UI because I mostly wanted to fit everything on here. But here we have another example where we're going to have lots of different actions the user can perform. We've got a filter, we've got a previous and next to page our pages, we've got something that says, all right, we only want 2 per page or 3 per page or 5. I only had 7 bits of data, so these are little numbers. In a real app, you might have 5, 10, and 25. But you get the idea. Lots of different actions that the user can perform. So how do we manage something like that? Well, if you are going to pre-get the data, which you would do if you have a small amount of data, say you only have the ordered products or the current out-of-stock products or some subset, not thousands and thousands of products, then you might pull the products down and then do the filtering and paging on the client. So if you're going to do it this way, and using the imperative technique, you would have a function, right? And you would pass in the products and the filter by and then write your code to do the filtering. Using a data stream and an action stream, your data stream again would be your products. You would have an action stream for your filter subject and filter action. Now notice that I have a behavior subject because I'm going to bind my filter products, and that's what I'm going to show the user. If I had a subject with no default, when they first brought up the screen, there would be nothing there because this little baby's not going to emit. Okay, so I'm using a behavior subject so that when all products are received, the filter action is empty, but it will still emit. So then I can perform the filter, which won't filter anything, and it'll show the user all of the products. All right, what about all of the other ones? Okay, so remember, this is called filtered products. This is taking our data stream and adding an action. Instead of adding all of the other actions on here, we can instead take this stream, this filtered products dollar, and we can think of this as kind of passing in this data. And we can do another combine latest with the filtered products and our additional action streams. So this is our current page and our page size. And we can write our code to correctly figure out which products to display based on their action. Okay, so looking at it from a data stream and action stream point of view, we get the data stream, which is our products, the action stream, which is the current page, another action stream, which is the page size. I'm not showing filter on here just because it didn't fit. Our combined stream then will give us the saw, rake, axe, the 1 and the 5. If the user then says, next, I want to go to the next page, we will get, again, the latest emitted item from the data stream and the latest from each action stream. So we'll get the data, the 2 and the 5. Then if the user says, okay, I want 10 per page, we'll get the data, the 2 and the 10. All right, a more common approach when you have lots of data is to get the data from the server. So we would instead, using an imperative technique, have a get products method and pass in the filter, the page number, and the page size, do an HTTP get, and get our data that way. Well, how the heck are we going to possibly do this with the declarative approach? How are we going to pass in these values that we need for our HTTP request? Well, you might have kind of picked up from some of my slides that that is how you kind of pass stuff in. You use something like combine latest. So here I don't have a data stream because I'm letting my backend do the work. I am combining my filter action, my current page action, my page size action, and then here is how I am passing in this data by doing a combine latest. Then here in my pipe, I can work with that set of data or access it. I'm doing a switch map. Again, I am doing array destructuring, so I can label each one of the values emitted from each of the streams. And anytime any one of them change, I'm going to get this code re-executing. I'm going to do an HTTP get and then pass in my parameters. The switch map is often called a higher order or flattening operator. And what it does is it takes an observable and it flattens it out to a simple observable. So here, combine latest is emitting an observable. HTTP get is emitting an observable of product array. And so the whole thing would return an observable of product array. By using a switch map, it flattens that, so we end up getting out of here an observable of product array, which is what we want our products dollar declared variable to be. Okay, so in this case, we don't really have a data stream. We have our action stream for the current page, our page size, and our switch map is going to be pulling down our data. So that would be our products. So our current page, again, we're skipping filter just for space. So our current page is 1, page size is 3, and we'll get back saw, rake, and drill. The user hits the next button, we'll get the next 3, bow, sword, and axe. If anyone picks up on that little hidden gem, it's my favorite movie. And then if the user then says, no, I only want 2 per page, depending upon how you code it, you might get bow and sword, or maybe you'll get drill and bow if it's smart enough to repage prior pages. And so those are our action streams. So the bottom line, data stream plus action stream is love. All right, so here's some links. That's my Twitter, and I have a sample application. This one is the one with the previous next buttons on the top. The pagination code is the one right there. And with that, I want to thank you all very much for being here this evening, or this morning, or this afternoon, or whatever it may be for you. Thank you very much.
Thank you, Deborah, for such a informative and good talk. Now, what I would do, I'll take, keeping time in mind, I'll take 3 or 4 questions from the chat, and we'll just try to answer them as shortly as possible. Is it okay?
Yeah.
Okay, so one of the question is, can we define any default value in combined latest when the value is unpredictable? And this question is asked by Niranjan Swain.
When the value is unpredictable?
Yeah,
is that what it says?
Can we define any default value in combined latest when the value is unpredictable? And the next question is by Saik Safiuddin, and he's asking, what will happen if one of the streams in combined latest fails?
If one of them errors out, the whole thing will error out. So you would get an error, and I didn't show error handling on any of those just because it doesn't then fit on a slide. Error handling is not very slide friendly, but it's incredibly important in a real application. But yes, if any of the streams fail, then the combined latest fails. And so you need to be really careful with error handling. Error handling is a huge topic in and of itself, and maybe that would be a good topic for one of your viewers to volunteer to talk about, because if you can wrap and encapsulate your error handling well, you can set it up such that an error in one of the streams won't necessarily take down all your action streams, because that would be a bad thing for your application. So there are some techniques. I've seen talks from like Ward Bell on some really good techniques for encapsulating your errors to ensure that they don't take down all of the streams you don't want it to take down. And I'm not sure about what the other one meant by
unpredictable.
Unpredictable. So,
Yeah.
You know, you can always default to a 0 or no default with just a subject. So I'm not sure you could default. You could do a behavior subject and pass a null as your default value. I'm not incredibly sure I understand the use case for that question.
Great, Deborah. So, and some of the question Ben has already answered inside in the chat. So, okay. So we are good to go for the next talk by Ben. And once again, thank you so much for your time. Early morning, 7 o'clock in the morning. You always inspire us. Thank you so much for everything you do for us.
Thank you so much for having me.
Thank you. Now our next talk is from Ben, and I'm a great fan of Ben. We know each other for quite long time now, and Ben, thank you so much for finding time for us. Ben is one of the core member of RxJS team. He is ex-Angular team member. One of the great guy, very inspiring, and thank you so much for taking out time for us. And today Ben is going to teach us how we can create a custom operator. So over to you, Ben.
All right, great. Oh, by the way, sorry, Deborah, I answered some of those questions in the chat. I did not know that we were saving the questions for you. So, all right. So what I'm going to be doing today, and I'm going to move my chat over a little bit. So if it looks like I'm looking to this side, it's because I've got a big monitor. I am going to, let me just share my screen. In particular, this one. Share. All right, hopefully everybody can see this. Get off Twitter, get off of this other stuff so we don't get any alerts. All right. What I'm going to be doing is I'm going to be trying to live code an operator from scratch that's kind of like a concat map or a merge map, but it's eager. So to kind of describe the behavior, the first thing I want to do is I kind of want to show you what a marble test looks like. And I'm going to do a simple marble test for merge map. So I've already got my RxJS dependency in here. I'm using Code Sandbox. Usually I use Stackblitz, but I'm using Code Sandbox here because it has this kind of testing capability. So I can go in here and I can say, describe my thing, whatever this is, and I can have a test. It should work. And in here I can just, expect true to be, and we'll make a failing test first, true to be false. That hopefully doesn't, if this passes, I quit. Okay, it didn't pass, that's good. And then we'll put that in there, make sure it passes. Okay, it passes. So we're able to write tests in this environment and kind of see that it passes over here. And what I want to do is I want to write some marble tests for merge map. And to write marble tests for merge map, first thing I'm going to do is I'm going to bring in merge map. And the reason I'm doing merge map, even though it already exists, is I just want to show you what a marble test looks like for kind of a known thing, because I'm going to make something very similar to merge map, and I want people to understand it. Maybe we'll test concat map too, we'll see. All right, to do this, we need to pull in the test scheduler from RxJS test. And we need to make sure that we create a new one for every time we have a test. So we do our before each. And the test scheduler, what it does is when you make a new one, you have to pass this function to it that gives you the actual marble representation and the expected, and it has to do like a deep comparison. So with this is using jest, that would only be spec.
Ben, sorry to interrupt. Can you just a little bit increase the font of the code?
Absolutely.
Yeah.
Is that better? All right.
Yes.
Okay, so we're going to do to equal expected. And this is just kind of our setup for the test scheduler. And then inside of our test, we want to use the test scheduler in what's called run mode. And run mode is this function that we kind of set up a bunch of expectations with marble observables. And at the end of this function, it actually kind of flushes a test scheduler and tests all these things synchronously and deterministically. So we don't have to wait for things like set timeouts to land and whatever, which is non-deterministic. You don't really know if set timeout when it's going to happen. So this makes us so we can run asynchronous stuff within a synchronous test. And it gives us these utilities like cold, which we can use to make a cold observable, and expect observable. So the most basic test we could do is we could say our source is cold and A, B, C, and it completes. And what this is each one of these dashes represents the passage of time. This represents a value, and by default, it'll just be literally a string of A. Passage of time, literally a string of B, passage of time, string of C, and then the pipe means a completion. So we're saying the observable is stopped right there. Spaces mean nothing. If I put this here, it's exactly the same as this. So spaces are just there so you can kind of move things around. And I can go in here and I can say const, here's what we would expect this to be. Spaces don't mean anything, and it would be A, B, C, go. So this is the most basic test in the world. We're going to expect the source observable to be expected. Hopefully this passes, and we can see that it does. And just to make sure that we're not wrong, see that failed because it's missing. It's got the wrong notification there. All right, now we want to test merge map, so I can show you what that looks like. Now testing merge map is a little bit trickier because you have to merge multiple observables together. So to do that, what I'm going to do is I'm going to say, I'm going to have an observable of A that's cold, and it'll emit a bunch of A's. Doesn't really matter what order, but I like them to be kind of neatly spaced out. And then I'm going to have one of B which is also cold, and it'll be, let's see, B. And I'm lazy, I'm just going to do this again, only this time. Boom. All right, so we have A, B, and C, these observables. We're not using them yet, which is why it's got the red squiggly. And what we want to do is we want to take our source observable, and we want to have it emit inside of a merge map. We'll call this results. Source pipe to merge map. And we're going to get a character here, in this case from the source of A, B, or C. And we want to like look up one of these things. So I'm going to cheat and make a little lookup here. And the lookup will be called, just be a record of string observable string. And it's got A, B, and C inside of it. So it's just an object with the properties A, B, and C that have these observables in it. And we're going to use that object in here to do a lookup. C. So here's our results. And I'm going to put my result in here. And that's going to definitely be wrong because this is not the right expectation. But I want to move my expectation up closer to where I'm working. And the thing is what we're doing is we're saying, okay, when A comes in, we want to map it to this thing. So this, I'm going to move it over so I can kind of see where it would line up. I'm going to erase this for now. And I can see that, okay, so I subscribe to A and merge map should give me all of these values out of here. It's like pretty much the same spot. That's great. And then when B comes in, it's going to subscribe to that one. So I can move that over to kind of line up. And then when C comes in, we're going to do the same thing. We're going to kind of line it up again as well. So these are all the spots where these things are supposed to come in. And what that's going to mean is I can go through here and just kind of eyeball, line it up. A is there. So not this one. We're getting them from up here and like pushing them down. In fact, I could even move these closer just to make life easier. And say, okay, so A is there, C, B, A, C, B, C, and then it should end there. So if I run this, we can see my test pass. I like failing tests, so we'll make it fail once just to be weird. Shouldn't be a D in there ever. Okay, that failed. If I was off by one, it should fail, it fails. So this is what a merge map, let me kind of get this stuff out of the way. I don't think I need this at the moment. This is what a merge map test would look like. Now, if we're going to test this with concat map, I can pull in concat map. We can make it look, it's pretty much the same. This is merge map, should work. Concat map is going to be cat map, and this is going to be broken because that's not right at all. What concat map is going to do is it's going to be like, oh, when I get A in, I have to wait for it to be done, and then I subscribe to B. And then after B, I have to wait for it to be done, and then I subscribe to C, right? And this one gets pretty long, but the result is definitely different. So I would go through here and I would say, all right, A, B, oh, C, I missed there, C, and then we're done there. All right, there, and that passed. So this is what concat map looks like. Now, one thing I get asked for, and here's where we're going to get into the operator that I want to make, is sometimes I get asked for something where it's like, why doesn't RxJS have an operator where we can ensure that it subscribes as quickly as possible, just like merge map does, but it preserves the order just like concat map does, right? So we want this thing that's kind of in between. And I'm going to call this, you can guess by the name up here, I'm going to call it ordered merge map. Excuse me, I'm just getting a drink. All right, so ordered merge map would need to look like this. So we're going to call this ordered merge map. First of all, we don't even really have an ordered merge map yet, but when we do, I'm going to import it from something right next to this, called ordered merge map. And right here, the call should probably look just about the same. This is all red because this isn't a real thing yet. And what I want it to look like is whenever A comes in, I want to subscribe to it right away. And whenever B comes in, I want to subscribe to it right away. And whenever C comes in, I want to subscribe to it right away. But this should look massively different because I have to wait for A to get done before I give any values from B. And in fact, I'm going to change B a little bit so this isn't tangent, just to keep there from being any confusion. I'm going to move that a little bit. So A should give me all of its values. And then right here, it's going to start getting weird. So I have to have a group that comes in here at the same time where I get A and B. I'm going to move this over a little bit more again, just to make my tests cleaner, because it doesn't really matter exactly where these things are. This is where we just want to make sure the tests are easy to read. So basically we're saying, oh, I've got a couple B's here. This should be A, B, B, all in one frame should show up because these showed up before these ones. And then I also am going to make sure that after that, I still get B, but C I shouldn't get until B ends. Oh wait, I shouldn't get an A here because this isn't actually admitting an A. This should just be BB. This is done. C comes in, we have to wait till B ends, and we're going to get all of C simultaneously. And I'm actually going to move this out, maybe add another C, so I can make sure that we get values from C afterwards. So C, we've got 3 C's before B ended, so we should get 3 C's there. And then after that, we get C and done. So what we're looking for here is we're looking for a situation where as we're mapping to these inner observables, we're subscribing to them right away, but we're keeping the values from, we're only allowing the values through from 1 until it's done, but we're keeping the values from the other ones and emitting those whenever the previous one is done, and so on. So this is going to be a tricky operator. I don't know if I can pull this off in today's talk because I've literally never implemented it before. So this should be pretty fun. Hopefully I can get it in the time allotted. All right, so ordered merge map. Let's jump to our bit over here, and we can hopefully kind of see whether or not our tests pass over here. So first things first, we actually need the function to be exported. Export function ordered merge map. And we're going to have to deal with 2 types, the incoming type and the resulting type from the inner map. There's an inner mapping function that we're passing to it that takes a value of T and returns an observable. And I'll just do observable, not observable input at this time, observable R. And let me import observable RxJS. All right. You're going to find out exactly how much I typo things today too, which will be really fun for you. Now, all of our functions, our operator functions, what they do is all of our operators actually return these operator functions, which take a source observable of T in this case, and returns a new observable of R in this case. So and the reason it's returning an observable of R is because we're doing some mapping and flattening in here. Subscriber. So our subscribers, where we're going to, when we next out of this, it's going to next out of our resulting observable. So this is our resulting observable from our operator. So now we actually at least have an operator. So this should look a little happier. Yeah, it does. And what we need to do inside of here is we're going to have to deal with a lot of different subscriptions. We're going to have to deal with the subscription to the source observable that's coming in, as well as all these inner observables. So I'm going to go ahead and I'm going to create a subscription that is going to be like my main subscription for the whole thing. And I'm going to return it here as my teardown. And this is a valid teardown. You don't always have to return a function. As a helper in RxJS, you can return a subscription. And then the first thing I'm going to do is I know I have to subscribe to my source. So I'm going to add to that source.subscribe. And we're going to have to do something with the value when we get one. We're going to have to do something with the error, which is almost always when you're developing an operator, you want to pass the error along, unless you're making some sort of error handling operator. And we're going to have to do something with complete. And you'll see, like, when the source completes, if you look at our test, when the source completes, we're not completing the result. So I'm going to leave that blank for now because we have to figure out what we're doing inside of here. Now, what we're doing with this is we're actually calling this function, and I'm going to leave a slight gap in here. I'm not going to do any error handling on this yet, so I can show you what that means later on, hopefully. I'm going to have to call that function to get my inner observable. So my inner observable is going to be function, pass the value to it. And then inside of here, I need to add to my subscription, this parent subscription again, add a subscription to my inner observable right away because I want to subscribe to all of them as soon as I create them. So subscribe. And then here we've got next, and it's going to have an inner value. We need to decide what to do with that. If there's an error on any of these, we should definitely pass it along and just terminate the whole thing. So we'll do that with subscriber.error. And then complete. We need to decide what we're going to do there. All right, so we've got our complete call. So now we're subscribing to everything, and that's great, but we're not doing anything with values yet. If I was writing merge map, I would just take all these inner values and push them out of my subscriber right in this spot. But that's not what we're doing. We're only doing that with one of these values at a time. So that's a little bit tricky. So now I have to think about this a little bit. We're going to be doing something inside of here where we need to kind of track the values as they come in from each inner observable. So I think I'm gonna create this thing. I'm gonna call it ordering for now. Just give me an array. I'm lazy for right now. I'm just gonna make an array of any because I want to stick things in here. And I think that every single time, so we want to subscribe to all these things. I think that we need some sort of context. So I'm gonna push these contexts into this ordering array, or maybe I'll call it context. How's that? That's a better name. So we'll call this context. And our context, we need to know what values are in it as R. These should be all values of R that are coming out of here. It's an observable of R. And it'll probably, well, first of all, let's just go in here and we'll just take context and then push values in there. Inner value. This is going to be a tricky one. I don't know. All right, so values. So we're pushing values onto that. And then what else? I guess we probably don't want to do that if it's the lead context value, right? So if we're going in here, like the next thing we're going to do is we're going to say contexts. I don't know why that's hard to say. Push our context onto it. So every time we get a value, it's saying here's a context. We'll push it on. If our context equals our context, so if our first value in our context is the same, then really we want to just tell the subscriber we're just going to push it out, right? Or subscriber next inner value, because we know that this one is the one that's in front. We're allowing that one to come out. If it's not, then we need to store it in some sort of in this values buffer. Okay. Now, what else do we need to do? We need to know, well, some of them could complete before, and so the context needs to know if we've completed. So we'll just say is complete. We'll start it off as false. And then in here, we're going to say context is complete, goes true. And what? I'm trying to think of what's the best way to go about doing this. So if we we have that now we know all of the values that have shown up except for the first one and whether or not it's complete. And when it's complete, if this happens to be the first one and we complete, we need to go and say, hey, is there any other context that we need to do here? Still thinking. Actually, you know what? We don't need to create a context if this happens to be length 0, right? Because if it's length 0, then that means that we don't need to be storing values for it. So how about this? I'm going to change the name of this to like buffer or something like that. So we'll have these buffered contexts, and we're going to say that context will be if buffer length is greater than 0, then you get 1. Otherwise, you don't. You get null. And then if context, so if we actually have one, ooh, what did I do? Jump to the end. If we actually have one, then we push it on. And what? But we need to know if we already have one, right? So how do I go about that? You know what, I'm going to go back to just my previous thought with just putting it all in the same array. All right, but the trick is that we don't want to push values onto it if it's already had values shoved out. So now we'll cross that bridge when we come to it. All right. So here's our buffer, and we've got our context in it. And inside of here, we're pushing these out. And if this happens to be complete, then we need to like check whether or not we need to flush the buffer, right? So I'm going to call something check flush. I'm going to go up here, and I'm going to add a little function that's going to help us out called check flush. Check flush is going to say what? If the first value in the buffer, first of all, if the buffer has anything in it, and this might even be a while. So while the buffer has anything in it, and the first value in the buffer is complete, then we need to take the first value out from the buffer, and we need to loop over all the values of first values and pump them out of the subscriber, which is value. All right, so we know we want to check the flush, and we want to say, okay, well, we're going to do this check flush where we say, okay, so we just completed this. If the first one in our buffer is complete, then let's pump all the values out of the subscriber, and then it'll move to the next one and say, is that one complete, and pump all the values out of the subscriber again. What else do we need to do? When all of this is over, we need to see if we have completed this yet. That's one area that we haven't covered. So let's just say, let's add this bit here. Let is complete. So this is the outer, I'll even call this is outer complete, just to make it more explicit. And right here, we're going to say is outer complete is true. And what we need to do is have like a check complete function here, and a check complete function here. Why is this complaining? Declared, but its value is never read. Oh, it's never read, that's fine. It's not defined. Is outer complete? Is outer complete? Did I close it inside of a closure that, oh, it's inside of the wrong spot, that's why. Move it up there. And check flush is in the wrong spot also. Move that up. All right, I like to move this a little bit closer to where it's needed. Okay, so here we have check complete. We need to create a check complete function, const check complete. And what this is going to do is say if the outer is complete and if there's nothing in our buffer, then we can complete the subscriber. See how we're doing so far. All right, so let's look at our thing. So we're getting some stuff here, but it's wrong, and that's fine. Let's look at what we're doing so far. So what we're doing is we're returning this observable. We are subscribing to the source is the first important bit of work we're doing. Every time we get a new value, we're getting the inner observable out of it. We're also creating this context for that inner observable and pushing it onto this buffer. And then we're saying what? Every single time we have a value from it, if it's the first one, we're just going to go ahead and next out on the subscriber. But if it's not the first one, we're going to push it, we're going to push into its own internal buffer. And then what? Nothing else really. And then we're saying if it's complete, we're going to mark that its context is complete. And we're going to do this check flush. The check flush says, hey, we know that this is done. So let's go and check our buffer and see if there's anything left in it. If it's complete, we take it out and we shift values out of there. Now this might cause some weird problems because the first value that's on there, we did push some of them out, right? What else? Then we go through here and we say, is this complete? All right, so then we go through here and we check complete. So the only thing that should be left in here when we go is if it goes to a point where it's like, hey, we do have something in the buffer. Oh, I can see where this might be wrong. So it'll come through here and say, is there something in the buffer? If there's something in the buffer there, it shifts it out. But on the next pass, it might have an item in the buffer that has values in it that's not complete, and we need to flush those out. So that's probably the source of our problem, because if we look here, we can see that this one completes, right? And so it's going to take itself off the front of that buffer, but this one here is going to be like, oh, well, I've already buffered up these two values, but I'm not complete because that doesn't happen yet. So our little loop here is a bit flawed. We need to do something where this not only removes the items that are complete, but also deals with the fact that the very first one in there might have values. So I guess right after that, we can say if buffer length is greater than 0, then we probably want to take the first one off of there for const value of buffer 0, get the first one and its values, or what? Actually, we could probably just flush it even. Values length is greater than 0. We're just going to take those off of there. Subscriber, not complete. Next, values shift. So this is going to pull the values off of that buffer and send them out. So see if that helps us at all. Still getting the wrong value, the values out at the wrong time here. So we were expecting 8 and we received 43. We're expecting 13. We got the so we're really off on this. Let me go check the test. So in our test, we have this. It should subscribe to all these right away. That I have no doubt. Here, maybe this stuff isn't lined up. Maybe because we pretty formatted that, it's off. So A is coming down there. A is coming down there. A is coming down there. Then here we should get our B's, BD. This one's off. There. C should show up Actually, no, this whole thing is off. Sorry. Our formatting got us. That's all right. So C should come there. B is done. C should go, and then here C should go there. Trying to make sure all this still lines up. Ah, look at that. Test passed. My test was wrong. Oh no, it didn't pass. Fooled me. All right. So just double checking this. This lines up. That lines up. That lines up. A gets done. We should emit 2 B's there. B gets done, or B emits 1. Then B gets done. We should get 3 C's from that. C and then there. Okay, so this looks, the test looks okay now, but we are still failing. And it's saying that on frame 43, it got an A. So this is doing something where it's waiting until it seems like all of this is done to emit any of this. So that's incorrect, or it's adding extras. All right, I picked a tough one. So what we're dealing with here is we've got this buffer. I think that my flaw is the fact that we're just kind of buffering everything and adding a context for everything. So let's look in here. In our inner next, we're saying that if we happen to be on the first context, we're going to next it out. But if we're not on the first context, we're going to add it to that context buffered values. So in the very first pass, which is our A, we're coming here and we're creating this one for A. And we're getting these values and we're saying, okay, so let's see how this builds up. So how about this? How about if we say, if value equals A, and this is our external value from here, right? We're going to console log our context just to see what's in there. I don't know why is this complaining. We'll always return false because whatever, we don't, that's fine. Take that, TypeScript. All right, so we're going to go and we're going to look at our console. So our console is saying, okay, so we're never actually pushing that on there, which is fine. It's saying that it's complete, which, because this is a stateful thing, that's fine. That's because we would need to actually like JSON stringify this to get the current state of it, because it's, all right. So it's never complete when it hits that, that's fine. All right, so it should never have that in there. Fair enough. And let's just go in here and say, emitting, what it's emitting. So right here, this is every single time we're getting an A, is in this spot. And it's emitting A, emitting A, emitting A, but here it's emitting B. And that is not correct. Buffer 0 should not be the same context here. Interesting. All right, well, why would it think that buffer 0 is the same as E? I'm getting some closure thing wrong, I'm sure of it. All right, but emitting C into the blah, 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 and it goes here. So that's why we're so far off, is because this should not be happening and this should not be happening. Also, the one thing that's interesting is the inner value of A. I think that it might be helpful if I went up here and I told this to clear console. Yeah. All right, so we're getting 3 there. It is only emitting A. So those other ones were just leftovers from the other thing. So we're actually okay, then emitting B and emitting C. So that console clear, because of this sandbox environment, was fooling me. I had to make sure we cleared our console in between each one. All right. Now, in fact, I'm going to move this console clear down to before each test. Well, no, I'll put it back up here. Sorry. All right. So the A part looks okay. It's when we get to the B that I think we've got problems. So I'm going to go back in here and get rid of somebody's console logs. And yes, I debug with console log all the time because I'm a horrible person. And we're going to go back up here and look at our check flush. So now I'm starting to think that here's our problem. So let's just see what it's flushing out here. Flushing value. It's not flushing any values. It's never flushing a value, really? That's super weird. Okay. See what it's getting inside of there. So the deal is that, oh, it's because it's only hitting, that makes sense. So A never got anything in it, so there's no values for it to flush. That makes total sense. Let's get out of there. I know that there's probably people screaming at me in the chat. I haven't checked over there yet. Inside of here is where it should start doing B. So if we still have this, let's check this out really quick. Log. See the first value that is in there. So we got our B's, and then C's. Oh, wait a second, that doesn't look right. So we have B's, and then C's, and then B's, and then C's again. So this is clearly getting to the point where it's not removing something. Why would it not be removing that? So after it flushes all these things out, B completes. And when B completes, it comes back up here. It says, hey, is there anything else in B? And it flushed it again. That's super interesting. So we check complete afterwards. Is it in our check complete? All right. Mildly confused by this, but that's okay. So while the buffer, if the buffer length is greater than 0, we take the very first one, and we're in here saying, hey, we need to get this stuff out of here, out of the first one, and we're still dealing with the first one. And the first one should be this now from now on. Maybe I've gotten too clever. This should definitely be 0. Okay, that's definitely 0. Let's see when each one of these things complete. Console log enter complete. Put our value there. Oh wait, am I not in the right one? Oh no, I'm not in the right one. I need to be up a little bit further. So enter complete. So enter complete A, and then we do BB. Enter complete B, we do CC. Enter complete C. Why is it doing it twice? Why am I repeating? Do I have 2 tests? Complete A should not happen twice. Interesting. Ordered merge map is right there. We're only doing it one time. Why is it doing it twice? Why is it doing it twice? That is an interesting thing. All right. So let's just say that it's very peculiar. I'm going to add a finalize here. All right. Now it's only doing it once because I added a finalize. That does not make any sense, but okay. Let's let's run that again. Yeah, that's super weird. What happens if I get rid of that? Magic. It's magic. Now it's only doing it. Now it's doing it twice. What in the world? I'm suspecting there's something weird with this test harness. All right. So let's go back and close our console. Let me move this out of the way a little bit. What happened to our test stuff? Yeah. I had our tests here earlier and I lost it. Where's the test thing? Now that vanished. Don't want to do that. Put this back. Oh my God, why do I suck at doing this? Show open editors. There it is. All right. So now we're actually saying all the tests passed. So all the tests passed we had finalized there. Congratulations, you're done, everybody. Let's just add finalize and you're good. It might also be that I had my test passing before and didn't realize it because my my tests were passing before. I was just fooling myself with my console logs. I'm sorry. I think that's very funny. All right, so we did a few things here and we got all this working. And you saw that the trial and error. I added some console logs in here to try to figure out what was going on. You have to consider kind of like what state you're tracking and these other things. Now, there is one thing in here that I did not do, and I want to show it to you. I'm gonna copy this test really quickly, and this is how you write tests, is just copy and paste, right? That's important. So it should pass along errors from the callback. Now, if I have this callback in here, and I'm just gonna say that normally it's gonna return what's in the lookup. But if C happens to equal character B, if that character happens to equal B, then I'm gonna throw new error bad, right? And this is not gonna pass. And what I would expect is as soon as I get this in right here, this should be an error. It should error out the entire thing. That's the expected behavior, is as soon as I get an error from any source that's bad, I want to see that error. And just reformatted everything again. Let me move this around. Thanks, prettier. All right, right there. Right there. Is that right? I'm going to move it over one. I think this is right. All right. So right there, we're just getting an error. And we don't need any values here, but we do need to pass the type of error, which would be bad. So this is what I'm expecting to happen, and it's not. And it's not because I didn't add any error handling for this call. So if you write a custom operator where someone's giving you a function, a user provided function, we need to make sure that that's handled. So in order to handle that, right up here where I'm calling my thing to get my inner observable, I need to wrap this in a try catch. So what I'm going to do is I'm going to say let inner observable equal observable R, and then try inner observable like that. And this is a pattern you're going to see a lot if you write your own custom operators. And when you get an error, you say subscriber error, pass along, and then you just return. Right? We don't need to do anything with that. This is toast. So looks like maybe, yeah, I got the test off by one. So my test is off by one. Down. There, it was off by one. Okay. Am I still off by one? down. Here, nope. Down. Should be right there. What's it complaining about now? It's saying on frame 9, we got a notification of false. Should start here. Should give us an A. He is coming. Oh. It's the mapping function that bailed on us, not this giving us a function. It was the actual mapping function. So it should happen when this is called. All right, so now I've handled my error scenario. And you'd have to go through and you'd want to add tests for a lot of these. Like what happens if I have, well, let's just copy this other one because it's a little bit more complete. What happens if I have an issue where, say, B errors like right there. If B errors right there, then this should err in roughly the same spot, which would be right here. Should be nothing after that. Of course, I have to reformat this again because prettier. All right. So that passes, that's fine. You know, another one would be what happens if I have an error on my source observable, like say instead of getting B, I get an error there. That would mean that none of the rest of these even really matter, but like right here, there would be an error instead. I guess I can move this over a little bit to make it prettier. So just to make sure that all of these different paths work. So that's it. That's effectively how you would create your own custom operator and test them with these marble tests. If I wanted to test it against a synchronous observable, it would just be like right there. Or, you know, what happens if one of these is empty and so on. You'd want to do that. Like if it was an empty observable, it might just be this exact same test. Only maybe one of these is totally empty. Oh, but not this same test. I'd probably go for the more complete one. So let's see, here's the more complete one. And you know, maybe this one is just seriously just empty. Boom, gives you nothing. That means that the results here would completely change to where you'd get A out until it was done, and then suddenly you'd get what? C, and then the rest of what's going on with C here. All right, so hopefully that passes. Doesn't seem to, but I could be off by one with this. Yeah. There, yep, so that's all passing and good. All right, so that's kind of how you would add different tests, and you know, hopefully you appropriately name your tests. You don't just say should work. But that's it in a nutshell. Again, the thing is here, I'll post this on Twitter so people can get an idea of what's going on. Maybe I'll add some comments to it. If you're writing a test like this, super important to add, like, don't just do what I did, because I'm live coding really fast. You're going to want to add like why this thing exists, you know, here. And I'll do that after this talk and post it. But don't just say what it does. Super, like really good professional developers say why this does what it does and where it does what it does. So that way people know why check complete exists, or why check flush exists, or why this particular loop is happening here. Like this is to deal with, you know, because the next one's going to be in here and yada yada. So I'll add all those comments in and send them along. I hope that everybody liked this. I've never made this operator before, just this exact moment. So it was a bit of fun.
When it was really good session, and I was looking at the comments, and people are saying they are enjoying seeing great like you doing debugging live. So that was really really good and learning for all of us. And we would share this code sandbox link on the description of this webinar YouTube video as well, and in the follow-up email which we sent to the people who are attending today. I don't see any much questions in the comment. They are mainly the suggestions, but there's no questions as such. And if there would be any, we would put the Twitter and Twitter handle of Ben and Deborah in the description of this webinar recorded video, and you can connect to them from there. So this was really good. Thank you so much, Ben, for taking time out for us and really inspiring us. Thank you so much.
All right, great. Thanks, everybody.
Thank you, everyone, and have a good evening ahead. And I'll see you in next webinar, which would be on 22nd of August. Thank you, everyone. Have a good evening and weekend ahead. Be safe.